There's a whole lot going on in the probability chapter of our textbook, but we're only going to talk about one little piece of it: discrete random variables and their expectation or mean and their variance. So let's start with the problem. You roll an ordinary six-sided die, and you're going to win $1 if you roll a 1, 2, or 3, $5 if you roll a 4 or 5, and $29 if you roll a 6. So here's our two questions. If you play this game many, many times, what's your winning on average? And how much variation is there? So this is an example of what's called a discrete random variable. Random variable is a numerical outcome of a random event. The event is rolling the die, and the outcome is winning $1, $5, or $29. Now, the first question I asked is, what's the average winning? And you might just think, okay, I'll just add up 1 and 5 and 29 and divide by 3. But that's not quite right, because your chances of getting $1 are a lot a lot higher than your chances of winning $29. In fact, the probabilities are here. The probability of winning $1 is 1/2, 3 chances out of 6. Probability of winning $5 is 1/3, 2 chances out of 6, and $29, 1 chance out of 6. So the mean of this random variable, or the expected value, is given by this formula from our text, which tells you to take each of the things that could happen, multiply by their probability, and add them up. And you see how I've done it here. You could get $1, and there's a 1/2 chance that that happens, so you multiply, plus 5 times 1/3, plus 29 times 1/6 equals 7. So if you played this game over and over, you'd expect to win, on average, of $7 per play. So if someone offers to let you play this game for $6 per roll, you should absolutely go for it. If they charge you $7.01, then it's not your favor to play, even though sometimes you'll win $29. And this is how casinos work. They make the average in their favor, the expected value. So they're very happy for you to win money sometimes, because the average outcome will be in their favor, not yours. That's how they get to have such fancy casinos. Okay, but what about the variability? If you play this game a lot, are your winnings going to be all real close to $7 or spread out? Now you can probably guess they're not going to be all that close to $7, because you win 1, 5, or 29. So there's going to be some spread, but how much spread? So again, the formula is kind of yucky, but it says take each thing that could happen, subtract that expected value, subtract that mean, square that, and multiply by the probability. And that number is called the variance. Sigma squared is called the variance of the random variable, and the standard deviation is the square root of that. So in this case, you take $1 you could win, minus 7, that's the mean, the average, square that, multiply by 1/2, 5 minus 7 squared times 1/3, plus 29 minus 7 squared times 1/6. The variance is 106.5. And to find the standard deviation, you take the square root of that, which is 10.3. And if you play the game many times, then on average you'll win $7. But the standard deviation of your individual plays will be about $10.30. So there's going to be a lot of variation, which is what you'd expect from seeing that most of the time you win 1 or 5, but every 1 in every 6 rolls roughly you win $29. A lot of variability there. Okay, so you do this one, more serious example. An investment opportunity has a 60% chance of yielding a 9% gain and a 40% chance of handing you a 2% loss, so -2. Use our formulas from above and convince yourself that the average return is 4.6% and the standard deviation is 5.4%. And here the mean tells you what your expected return is. So if this investment has an average 4.6% return, but the standard deviation tells you there's quite a bit of risk involved. And there's variability is 5.4%. So use our formulas and see if you can do those two. If you do this, or when you do this, I should say, don't make that 9% 0.09, but keep it as 9. It's just the thing that they're measuring is percent, and this 2% you should put in as 2. And that's all we want you to have for now on this.